Okay, welcome back to my YouTube channel. During our last lesson, we learned something about density. Yes, today our topic is what? Relative density. Relative density is different from what? Density. Yes, it's different from what? Density. So our topic for today is relative density. Now, what is relative density? Relative density of a substance is the ratio of the density of the substance to the density of water. Yes, relative density of a substance is the what? Ratio of the density of the substance to the density of water. Yes, so as soon as we hear ratio, it means it gives what? Comparison. Right? We are comparing two things. Yes. So we are comparing the density of a substance to the density of what? Of water. How am I getting it? So the density of water is constant, but the density of a substance can be anything. It can be kerosene, petrol, or alcohol as well. Are you getting it? Yes. So relative density of a substance is the ratio of the density of a substance to the density of water, which means that you are comparing these two things. The density of a substance, which can be anything, to the density of what? Of water. You are comparing them. Okay. Now, it gives the comparison between the density of the substance to the density of water. As I said, relative density deals with what? Comparison, right? So we are comparing the density of a substance to the density of water. So for the density of a substance, if I give it that of kerosene, it means you are comparing the density of a kerosene to the density of what? Water. You are comparing them. That is what? Relative density. That is relative density. You are comparing the density of water to the density of water. Right? Okay. Now, relative density has no units. Yes. During our last lesson, we learned that density has what? Units. Density has units. And the units were kilogram per meter cube or grams per centimeter cube. Yes. So density has units. But for the relative density, it has no unit. So it means if I give you any work and work it out, you're able to get a certain answer, maybe 1.02. You are not supposed to include any unit because relative density has no what? Units. Relative density has no units. So if you get 5.0 as your final answer, you are not supposed to include any units, right? Because relative density has no units. Thank you. So we have this experiment here. We have this experiment. It said determination of the relative density of kerosene using the relative density bottle. Yes, as I said, the density of a substance can use anything. So for this experiment, they are using kerosene as the relative density of what? Of a substance. They are using what? Kerosene. Okay. Now these are the apparatus that we are going to use for the experiment. So we have electronic balance, kerosene, water, relative density bottle, picker, and what? Funnel. Yes. So these are the materials we are going to use for the what? The experiment. Yes. So during the method or during the procedure, we are going to see or observe how we are going to use each of the materials for the experiment or the functions of those materials being mentioned. Okay. So now the method. The first one says determine the mass of an empty relative density bottle. How can I see relative density? This is a symbol for relative density. Let's come here. I'll even forget that one. I forgot it. Yes. This is the formula for relative density. So if you have been asked to determine the relative density, this is the symbol for it. It's equal to density of a substance over what? Density of water. Relative density is equal to density of a substance over density of water. So if I give the density of a substance as 2 what? Kilogram per meter cube, and I give it the density of water as 1.0 kilogram per meter cube, then that one to solve it without any unit. So this is the formula for relative what? Density. Okay, now let's come back to our experiment. Okay, so I have already mentioned the materials we are going to use for the experiment. So now the method. Okay. First method. It says determine the mass of an empty relative density bottle by using an electronic balance and record this as M0. Yes. So you use the electronic balance to what? Determine the mass of the what? Empty relative density bottle. The relative density bottle is like this. Yes. So first of all, you what? You put it on what? Electronic balance, and what? You determine the mass of this empty relative density bottle. It is empty, nothing is inside. Empty relative density bottle. You put it on electronic balance and you determine the what? The mass of it. When you are done determining the mass of it, we will call it as what? M0. M0. So now we know the mass of the empty relative density bottle, right? Okay. Now the second method says fill the bottle with water and reweigh. Yes. So now we fill the what? The relative density bottle with water and you put it on the what? Electronic balance again and reweigh it. Yes. After I record this mass as M1. Yes. So when you are done with that one, you record the mass as what? M1. You record the mass as M1. Okay. Now we are continuing. When you are done, it says the third method is empty the bottle and dry it. Yes. So when you are done, you empty the bottle and dry it. Why? So why are you supposed to dry it? You don't want any error, right? So you dry it so that the water, the small water that will be left inside, can even what? Evaporate, right? Yes. So that you won't get any water inside the bottle again. You don't want to encounter any error for that experiment, right? Okay. Now, the fourth method says refill the bottle with kerosene and find the mass. Yes. So when what? You empty the bottle, then you dry it. After that, what? You fill the bottle. That bottle with what? With kerosene. Then what? You put it on the electronic balance and do what? And what? You reweigh it, or what? You determine what? The mass of it, right? You determine the mass of it and record that one as what? M2. Record that one as what? As M2. I hope you are getting it. So the method is so simple as well. First, the empty bottle, you weigh it using the electronic balance and determine the mass of it. You get what? You record that one as what? M0, right? When you are done with the empty bottle, then you fill it with what? With what? Water, right? Yes. You fill it with water, then you still weigh it again. Then that was M1. When you are done with that one, you empty the water from the bottle, then you dry it. After that, you put what? Kerosene inside the relative density bottle. Then you weigh it, and that one you call it as what? M2. I hope I'm getting it. Okay, thank you. Results. So this is the results concerning the method that we just read or just went through. These are the results. So the mass of empty bottle, we recorded it as what? M0, right? The mass of the empty bottle, we recorded it as M0, and the mass of that empty bottle plus water. If you put the water inside the empty bottle, now it's what? Is the bottle with water. Yes. So that's one you weigh it, you call the volume of it or the mass of it as what? M1, right? And the mass of the bottle plus the kerosene, you call the mass as what? M2. Then the mass of water only. Now what will be the mass of water only? Yes. What will be the mass of water only? The mass of the bottle, empty bottle is M0. And the mass of the bottle plus water is M1. So for you to get the water only, you're supposed to subtract the bottle only from the what? From the bottle plus water, right? Yes. So you're supposed to subtract this one from this one. Then you get this one what? Only. How have I gotten it? Yes. So for you to get water only, you're supposed to subtract that of the bottle from it. Then you get water only. Yes. You get water only. Okay, because it's like water and water minus water. So the bottle, you take away this one, then you get water. How I get it? Yes. So we're able to, so for we to get water only, subtract the M0 from the what? M1. Like this is so easy as well. And mass of closing only. For you to get the closing only as well, for you to get the closing only as well, you're supposed to subtract the what? The M0, that's the empty bottle, from the what? From the bottle plus what? The closing. This is the bottle plus closing, M2. So you're supposed to subtract the M0 from what? M2. So that's what? M2 minus what? M0. That will also help you to get the mass of what? Of the closing only. Now, this under formula for relative density. There's another formula for relative density. The first one says relative density is equal to the density of a substance over the what? The density of water. Yes. Now, this is another formula for it. So relative density is equal to mass of closing or mass of a substance, right? But for this experiment, we are using what? Closing. So mass of a substance, which is the closing, over the what? The mass of equal volume of water. Yes. So the mass of the what? Of the water in that what? Experiment. So this is another formula for what? Relative density. Don't forget it. Okay. Now, so relative density is equal to M2 minus M0. Yes. The mass of the closing. Mass of the closing. M2 minus M0. Yes. What is the closing? It's mass of closing only. Closing. That's the substance you want. Mass of the substance. Closing. So for you to get the closing, you have subtracted the bottle from the what? The bottle plus the closing. So you're able to get the closing only. That's what? M2 minus what? M0. Okay, so M2 minus M0 as the substance. Over what? M1 minus M0, which is what? The mass of the what? Of the water. Yes, M1 minus M0. So for you to get the water only, supposed to subtract this one from this one. So M1 minus what? M0. So now we have able to get our formula for what? Finding relative density as well. So relative is equal to what? M2 minus M0 of what? M1 minus M0. I hope I getting it. Yes. So you can use this formula to what? Solve a lot of what? Questions. We work with a lot of what? Examples on the board. Then it will deepen your what? Understanding concerning this formula. Thank you. So now differences between density and relative density. Differences between density and relative density. Now we have learned about the density and relative density. So now we can see the differences between them. So the first thing is in that density it has what? Unit, but relative density has no unit. Yes, density it has what? Unit, which is kilogram per meter cube. But relative density has no unit. So you can use the word units of them to what? Differentiate between them. Density has unit. Relative density has no what? Units. Okay. So the second one is saying that density, it is the mass per unit volume of a substance. Density is the mass per unit volume of a substance. Whilst relative density, it is the ratio of the mass of any volume of a substance to the mass of equal volume of water. So that one too, they use their definition to differentiate between them. They use their definition. So it's the mass per unit volume of a substance. When it comes to density, it's the mass per unit volume of a substance. But relative density is dealing with what? The ratio of the density of a substance to the density of what? Of water. So the second one is using their what? Definition to distinguish between them. And based on their definition, they are not the same. Okay. One is using other load, other one is using the other load as well. Okay. Now, density. There may be errors in volume measurement. When it comes to density, there may be what? Errors in volume measurement. So for density, the probability that you will encounter some errors in your work is what? It's high. However, getting it is high. But when it comes to Relative density, there's a high degree of accuracy in all measurements. Yes. So this was high accuracy. I'm not saying that you did not encounter any error, but it was minor, like the accuracy was so high, unlike the what density. How about getting it? Yes, so density, you might the chance of getting some errors in work is high, more than that of what that of the relative density. Yes. So based on density and relative density, you can use this one to what? Distinguish what between them. These are some of the differences between them. Okay, thank you. Okay, so now we are coming to solve more examples about relative density. Yes, we are coming to solve more examples about relative density. So this is example one. It says a metal block weighs 1.8 Newton in air and 1.6 Newton in water. What will be its weight in a liquid of relative density 0.65? 0.65. A metal block weighs 1.8 Newton in air and 1.6 Newton in water. What will be its weight in a liquid of relative density 0.65? Okay, so now let's solve it. A metal block weighs 1.8 in air, 1.8 Newton in weight. So weight in air, weight in air is equal to what? So weight in air is weight in air. I'm representing it like this one. W weight in air is equal to 1.8 Newton and 1.6 Newton in water. So weight in water, right? Weight in water. I'm representing it as W weight and water is what W as well, right? Small W. Okay. So that one is what 1.6 Newton. 1.6 Newton. 1.6 Newton. Then what will be its weight in liquid? So weight in liquid. In liquid. That's W and liquid is what? Small L, right? For that one, bro, you don't know. Of relative density 0.6. So relative density is equal to what? 0.65. Relative density is equal to 0.65. So simple. Weight in air we represent as what? WA was weight. W A starts with A. So A, small a, 1.8 Newton. That's in the question. Weight in water. W for weight and small w for water. Yes. Then weight in liquid. W for weight and small f for liquid. But that one you don't know. That's what we are looking for. Then relative density was given to us in the question as 0.65. As I said, it has no other unit. Okay. Now, let's write our formula. You know that relative density is equal to density of a substance over what? Density of what? Of water. Right? So RD is equal to yes. So this our what? Formula, right? Yes. Density of a substance over density of what? Of water. And the substance was liquid, right? Yes. But for you to get the density of the substance, supposed to subtract from the air. For you to get the density of water, supposed to subtract from the air. Like how we did the experiment, right? Yes. M2 minus M0. M1 minus M0, right? Yes. So like how we did the experiment. Okay. So this is the formula for the question. Okay. So now, RD. Sorry. So RD, that's relative density was given to us in the question. Like it was 0.65 equal to weight in air, that's 1.8 minus weight in liquid, you don't know. That's what you're looking for. Then 1.8 minus what? 1.6 is in liquid. Okay. So if you continue, get 0.65 is equal to 1.8 minus WL over 0.2. Yes, 0.2. I'm continuing from this side as well. So you get 0.65 multiplying this one, 0.2 is equal to 1 point. As a physician, this solution, like solving something like that, shouldn't be a problem to you, like, okay. Then minus your mean. Yeah. Okay. So I have my calculator here. 0.65 times 0.2, you get 0.13. So 0.13 equal to 1.8 minus W. Yeah. So this one can come here, right? It's negative here. One is crossing the equal sign, which will positive. So the U is equal to 1.8. This one is standing here, so positive. This one is coming across, so it's what? Minus 0.13. Okay, so let me point on my calculator. 1.8 minus 0.13. Okay, so now I'm having WL, that's weight looking to be 1.67. 7 watts. You can add the watt Newton to it, right? Yes, 1.67 Newton. So that is the what? The weight in what? In liquid that we're looking for. The weight in liquid that we're looking for. I hope the solution was so clear, right? Yes. So you will go to example 2. Thank you. So example 2. It says a liquid has a relative density of 1.22. Calculate its density. Yes. And they have given us the density of water as what? 1.0 times 10 to the power 1 kilogram per meter cube. Yes. So 1.0 times 10 kilogram per meter cube. Okay. So now you know that relative density is equal to density of a substance over density of water. Yes. Relative density is equal to density of a substance over density of water. Now, the relative density was given to us in the question as 1.22 is equal to density of substance is equal to for that one, that's what we are finding, right? So density over density of density of water was also given us in the question of 1.0 times 10 to the power 10 to the power what? So times that unit on it. Okay, so now we get 1.22 multiplying the 1.0 times 10. That's equal to density of a substance. So let me use my calculator. 1.22 multiply 1.0 times 10. That's 12.2. So 12.2 got density of a substance. So therefore the density 12.2. Then you include the units, right? 12.2 kilograms. Okay. Right. 12.2 kilograms per meter cube, which is so simple. As soon as you're able to get to this side, the rest is mathematics. And as a physician, you're also able to arrive at the final answer. Yes. For being a physician, math is simple. Just okay, sure. So that's the final answer. 12.2 kilogram per meter cube for this question. They give us the relative density, they give us the density of water, then they say you should calculate for the density of a substance. So papa, mathematics, the cost multiply, and able to arrive at the answer. Then include the units as well. You are there. Thank you. Okay, so now example 3. Example 3. And I think this will be our final example as well. Then I'll give you the exercise. I think we are in this at 5 or something like that. Yes. Okay. A simple hydrometer of mass 50 grams floats in a liquid of relative density 1.4. Calculate the volume of liquid displaced by the hydrometer. Yes. So calculate the volume of liquid displaced by the hydrometer. And the density of water was given to us 1 gram per centimeters cube. Yes. 1 grams per centimeters cube. So we are finding what? The volume of the liquid displaced by the what? By the hydrometer. We are finding the volume of the liquid displaced by the hydrometer. Okay, so now you know that relative density is equal to density of what? Density of liquid over density of yes. So relative density equals the density of liquid, that's a substance, over the density of what? Of water, right? Okay, so now let's check. So relative density was given to us in the question as 1.4. 1.4, right? Because so the density of liquid was not given to us in the question. Okay, so we're supposed to find it. Density of liquid over then the density of what? Of water was given to us in the question as 1 gram per what? Centimeters cube. Right. So now you can cross multiply and find the density of what? Of liquid. Right? Yes. Okay. So 1.4 times 1. Yes. Times 1 gram per centimeters cube. Okay. Density of liquid. Yes. Because the density of liquid. Okay. So now we get so therefore the density if you multiply it, you get 1.4. 1.4 is multiplying 1, so you still get the same thing. So 1.4 gram per centimeters cube. Yes. So the density of liquid is 1.4 gram per centimeters cube. So you continue for this. So I think I have to put that in so that I can multiply it. Now we have the density of the liquid as 1.4 gram per centimeters cube. Okay. So now we know the density of liquid. Density of liquid is equal to mass of liquid over what? Volume of liquid. Density of a liquid is mass of a liquid of what? Volume of a liquid. So you already know the density, the formula for density, right? Yes. So that's why we will arrive at this one. Okay, like as. So P, 1, and 1, and 1, something like that. While that one is this one is density of the liquid. We already know the answer for that. The mass of the liquid over the volume of the liquid. Right? Okay, so density of liquid is this one. That's what 1.4. Okay, 1.4 gram per centimeters cube equal to the mass of the liquid. From the question, it says the mass is what? 50 grams, right? So the mass is what? 50 grams. The mass is 50 grams. So now the volume of liquid. The green one, that's the volume of the liquid space. You don't know, right? So for you to get this one, what do? You cross multiply, right? So for you to get this one, but you cross multiply, you get something like the 1.4 gram per centimeter cube. It's equal to what? 50 gram. Then we divide both sides by this one, so you get 50 grams over 1.4 gram per centimeter cube. Yes, or centimeters. So let me use my calculator. 50 divide 1.4 is 35.71. Then you get what? Centimeters cube, right? Centimeters cube. Yes. So therefore, the volume of liquid displayed is 35.71 centimeters cube. So that is all the final answer. First of all, we solve for that of the density of the liquid, in which the parameters that we're taking. After that, the density of liquid is equal to mass of what volume. The mass is in the question. If you're facing that one, you're able to what? Arrive at the what? At the final answer. Thank you for enjoying today's lesson. I'll send the exercise 5 on the WhatsApp platform so that you can do it and send it to me. Thank you.